So this project, UV light, is solving a problem, and that problem is our environmental footprint with the use of fungicide. And as we all learned this morning, fungicides or pesticide in general and diesel are contributing 75% of our carbon emissions. So we need to address this. Now, I have a question for you. Can you guess the amount of fungicides that we are spraying annually in our vineyards to control powdery mildew? Can you guess? Well, keep that number in your mind. And now look at this graph. Not the sprayer, the graph. So when you look at the graph, you can see clearly that in 2025, this past season, we sprayed 1,912 tons of fungicides, only for powdery mildew. And in 2023, we sprayed a record high of almost 2,000 tons of fungicides to control powdery. And in general, as more land is converted into vineyard, our fungicide application keeps increasing. So we are all aware of the side effects of fungicide on the environment. Fungicide, especially when they are broad spectrum, they can kill both target and non-target or beneficial fungi. But also, if the same active ingredient is applied repeatedly, it can lead to the development of resistance. On top of that, spraying itself consumes diesel, and diesel is a greenhouse gas, or emits carbon, and carbon is a greenhouse gas. And we also have other side effects like soil compaction. I can keep giving you more negative effects, but I don't want to worry you too much. We are all aware of that, so I will leave it there. So conscious of the negative side effects of fungicides, we want to address this problem. So how can we fix it? Well, we are testing with this project an alternative to fungicide. And that alternative is UV light. So UV light has some benefit. So a few that I would like to mention is that first, it leaves no residues on your grapes and your wine. UV light is also environmentally friendly in a sense that the operator or organisms are not killed by it, or it's not toxic. On top of that, it can be applied during windy, frosty, cold days, and therefore you don't have any restriction when you want to apply it due to weather. There is no spray drift when you're applying your UV light. UV light can also potentially be cost-effective. We will have to demonstrate that, but there is a potential there. Another thing is UV light can be deployed using autonomous, remotely controlled vehicles, and they are usually lighter than a tractor, and they are working on electric power, so no diesel emitted here. So when we consider all these benefits, I forgot one. There are some anecdotal data showing that the use of UV light in the vineyard can actually improve thiols on your wine, but we still have to demonstrate that. So when you consider all these benefits, you feel like we have to test this. We have to look into this to see whether it works. And that's what BRI did. So BRI partnered with Agri-Automation, the provider of the technology at the moment, with Whitehaven, and with A Lighter Touch. So these are our partners in this project. So BRI partnered with them to start this wonderful project. Now, what is UV light? We need to understand the concept itself. So UV light is a form of light that is emitted by the sun. Part of it is blocked or filtered by the ozone. Part of it reaches the Earth's surface. Now, there are 4 types of UV light. So you have, and they differ in their wavelength, as you can see in that graph. So you have UVV, or vacuum UV, UVC, the one that interests us, UVB, and then UVA. Now, UVC is the one that kills microorganisms, and the optimal wavelength is 254, or to be more precise, 253.7 nanometers. Now, how does UV light kills microorganisms such as powdery? Well, again, I'm coming back with DNA. We saw a lot about DNA this morning, but I'm sorry, I won't be long. So this is the DNA molecule. And so what UV light does is when a cell is exposed to UV light, the radiation goes directly into the cell, into the nucleus, and they alter the composition of your DNA. So these two components are usually separate in the DNA molecule, but when exposed to UV light, they bind together, and that modification actually stops the cell from multiplying, and over time the cell dies. So that's how UV light kills a cell. Now, if this modification happens during the day, the cell or the DNA can recover from that damage. However, when left in the dark for at least 4 hours, that repair mechanism doesn't happen and the cell dies. And that's why UV is applied at night and at least 4 hours before dawn for high efficacy. So, there have been a number of research overseas on UV light, UVC light, and its effects on controlling powdery. The only one I would like us to discuss is this one that was done at the University of Cornell. So they found out that when UV light is applied at the rate of 200 joules per square meter twice weekly, you have a good control of powdery at the same level as the standard fungicide application of the grower. And this is the case both on leaves and on bunches. So we wanted to test that here because we had the technology, we have the vineyard, we have the grapes, and so why not test it and see whether that can apply here and help us save the environment by applying less fungicides. So here is a video that presents or introduces our project. The industry is fully reliant on synthetic fungicides to control diseases and especially powdery mildew. When broad-spectrum fungicides are used, they kill both beneficial and the target fungi or pathogen. And on top of that, they are also toxic for the environment, and they can also be toxic to the person who is applying them. When you apply the same active ingredient on and on and on, you are likely to develop more resistance over time.
The aim of the program is to see if we can reduce our fungicide input by 50%. We're trialling it on Sauvignon Blanc because of the dense canopies, and we want to test it and prove that we can actually do the applications in Marlborough.
This technology emits UVC light or UVC radiation at levels that will damage the DNA of the fungi. They are unable to spark that repair mechanism at night. They only do it during the day. And so that's why we are applying this technology at night. Cool. When I watch that video, I have the feeling it's a science fiction movie, especially at night, when you see that green glow. So the goal of this project, or the objectives, are first to demonstrate the efficacy of UV light in controlling powdery mildew and reducing our fungicide application by at least 50%. The second is to evaluate how UV light or UV-treated bunches can affect our fermentation and the wine quality. And finally, to develop resources to allow growers to fastly adopt this new technology. So to run our trial, we needed a vineyard. And it wasn't easy to select the right vineyard because we wanted a block that had, relatively shorter rows, between 100 and 200 meters long. We also wanted a vineyard planted to Sauvignon Blanc 4 cane on a VSP trellis on a relatively medium to fertile soil. We wanted to have that deep, good, dense canopy of Sauvignon Blanc to see whether we can really push this technology to the limit and see what it can it can give. We also wanted a relatively flat block to allow the mobility of the robot, and a shed nearby to recharge the battery of both the robot and the UV machine. So we want to thank Whitehaven, who graciously provided that block. On top of that, there are many wine companies that we approached, and they were willing to help. I think of Pernod Ricard, Indevin, and Delegate. Unfortunately, the block that they were willing to offer didn't match all these criteria, but we are very grateful that they were willing to assist to help us run this project. So this is the machine that we used. It is called the Grapevine UVEX. It has two components. The top part is the one that emits UV light. So you can see here you have the two arms and the panels. They are called cassettes. And each panel has an array of 12 UV lamps that emit 400 watts. And that is about 30% of the 200 watts are UV light. The bottom part is the barrow. It's an automated, autonomous platform that carries the top part. And the barrow is made up of different sensors. You have LiDAR, GPS sensors, you have cameras. So this is the platform that allows that autonomy of navigation within the vineyard. Now, the energy output of this lamp, as I indicated, is 200 watts, but the amount that reaches the canopy of the grapevine is 140 watts per square meter, and the barrow was driving at 1.5 meter per second, and that meant it was delivering an irradiance dose of 120 joules per square meter. So this is the amount of UV light or energy that was delivered on the canopy. We tested 6 treatments. The first one was the grower standard spray program. The second was, and that spray program was 10 days return period. We decided to reduce that frequency by half. So that was the second treatment, GS20, so returning every 20 days. And the third treatment was a combination of UV light and the grower spray program. The third, this one was UV application every 5 days, and then UV application every 10 days and every 15 days. And of course, we did disease assessment. We sampled 100 leaves, scored powdery on those leaves, and we also sampled 50 bunches and scored them as well. We scored severity and incidence, and we did it over 3 time points. So pre-bunch closure, veraison, and harvest. So what did we get? How did UV light perform? Well, this shows us what we scored on leaves. So on leaves, when we did the first assessment at pre-bunch closure, this is what UV light every 5 days as a standalone treatment gave us. So this is on the the vertical axis, you have severity, and on the x-axis here, you have incidence, and this red line is the 5% threshold. So UV light as a standalone was just at the threshold by pre-bunch closure. The combination was below that threshold, and 10 days and 15 days were around 10%, so well below the 5% threshold. Now, when we did our second assessment, this is what we've got. So the combination of UV light this combination was mainly sulfur. So UV light and sulfur. So it was still sitting close to the 5% threshold. However, UV light 5 days, 10 days and 15 days were sitting around 15% of powdery on leaves. Now, what about bunches? So here on bunches, when we did the first assessment on the 6th of January around pre-bunch closure, again, we can see here the combination was below the 5% threshold. UV light as a standalone, well, every 5 days was still sitting just below that 5% threshold, but the other 2 treatments were well below that. Now, a few weeks after, when we were scouting our vineyard, we noticed that the disease was pretty fast, especially on these 2 treatments. And so we decided to intervene by spraying some fish oil and then carrying on with the grower spray program and increasing the frequency of our UV light treatment. So we're now applying UV every 3 days. And then after that, this is what we got. Now, this can look bad, right? But we faced a serious problem. The problem was any bunch that was clean was scored 0. But when there was a mark, we scored it as disease. Now the problem is, UV light is not a preventative treatment, it's a curative treatment. So each time UV light was passing and drying or killing the powdery that developed, actually it turned dark gray. So live powdery and dead powdery, we all scored it as powdery. And so that's why this number are higher. Now we tried to review our scoring system, and then when we came at harvest to do our score, this is what we've got. So around harvest, this treatment, the combination, was still below the 5%. This is the 5 days return period for our UV light treatment as a standalone. This was somewhat around 13%. And these are the two treatments where we intervened that were sitting, this one around 7% and this one 20%. So there was a lot to learn here. It was new, and we were learning as we were running the trial. And this is how a clean bunch looks like. This is a bunch with a live powdery, and this is a bunch that has been UV treated. So it was a little bit misleading, but we learned that dead powdery and live powdery, we need to separate them to distinguish them in order to have accurate representation of how the technology is performing. So what is the take-home message from the first season of our trial? Well, applying UV light every 5 days at the dose of 120 joules per square meter, controlled powdery up to pre-bunch closure. But from veraison to harvest, the control was not as efficient as the grower spray program. Now, we've learned a lot from this first year, and these are the new areas we would like to focus in the second season of this trial. We want to improve coverage and penetration of UV light. And one thing that we've learned is that the dosage that we were applying was not high enough. You remember the paper that I referenced? They were applying 200 joules per square meter twice weekly, and yet we applied 120 joules weekly. So one thing we will be doing this coming season is to increase that dose as well as the frequency. The other thing, and how are we going to do that? Either by increasing the output of those lamps or reducing the speed. So those are the two ways we can reach that irradiance dose. The other thing we are discussing with the provider of the technology is modifying the UVEX. This is the model that was used in the US, so it's an over-the-row prototype, and therefore UV light is coming from both sides of the machine and bouncing inside the canopy, so you have more coverage. And this is the one that we are using, which has panels on both sides, so we are only irradiating one side of the canopy. We believe that if we get a prototype similar to this one, we can improve the efficacy and efficiency of UV light in treating powdery. The other thing that we will be reviewing, as I already indicated, is the way we are scoring and the frequency at which we are scoring. We're also going to improve that. And we would like to find the best combination. Remember, the target we set is 50% reduction in fungicide, not 0, not 100%. So we want to find the best combination we can have between UV light and fungicide to be able to bring down our fungicide spray annually. And finally, we will be considering the effects of UV light on winemaking, sensory, and chemical composition of our grapes. So this project was funded and supported by New Zealand Wine Growers, A Lighter Touch, Agri-Automation, and Whitehaven. And the team, this is the wider team, so many people really contributed to this project, and we would like to thank all of them. And you can see the BRI team here makes up most of it. And we want to thank all those who contributed to this project. Thank you.